Welcome, it's the RC Renegade here. Today we are talking about your RC car and energy management. A lot of RC cars are built to run on either 4S or 6S batteries. I personally run my car on 4S batteries, but the 6S battery cars can go, between 50 and 60 miles an hour or faster. When you get up to those speeds, that's a lot of force on these cars in the cornering. When they hit bumps, there's just a lot of stress on the components. So let's talk about how the manufacturers build these cars to be able to withstand such speeds and such abuse. So for RC cars and energy management, these cars deal with a lot of speeds and just forces acting on them when you drive them fast. And so how do they handle all that stress? Well, first of all, this car is built with a big rear wing. And just like Formula One or IndyCar, these cars use aerodynamics to their advantage. When this car is driving at speed, wind and air go over this rear wing, which pushes down on the back end of the car and gives the tires more grip. More downforce provides more grip to the tires, which means more speed and control for the driver. Now, you'll notice on this particular car, the underside of the car has this metal chassis that the whole car is built on. This metal chassis that runs the length of the car, this is machined, and so it's just thin aluminum. And the reason it is thin is for weight reduction and also for cost saving measures on the manufacturer. And so what the manufacturer did to help the longevity of the car is they built these like A-arms that come out from the car, but they're made of plastic. They're not made out of this aluminum like the rest of the car. The reason these are made of plastic is for energy management. So when I get into an accident and I hit something like I have and will do in the future, even though I don't mean to, it's just part of the hobby. If you hit something and you hit like a post or a pillar that's right here, all the energy is absorbed into this section right here and these arms on the front. And you want the energy to be absorbed there and not to be transferred to the rest of the car, because if the energy is absorbed here and this arm breaks, then that is okay. If this arm was made of metal, for example, and this arm was very rigid and it did not give at all, then the energy from the impact would be transferred to the rest of the car. That would damage electronics, and more importantly, that would damage the metal chassis on the underside of the car. The reason that is such a big deal is if that chassis were to get warped or were to get bent, the car would not drive straight. It would drive not even. It would not be fun to drive at all. So popping cover off here, you can see all these electronics here are mounted on the chassis that I just showed you guys. And you can see on the bottom of the chassis, there are a ton of screws that hold all these in. So would it be a lot easier to just replace like one small section here, or to have to pull all these screws out to replace the chassis? It would be a lot easier just to replace this one part right here than to replace all of this, remove all of these parts, to remove the chassis just to get a replacement to build it back up again. Now, another interesting feature on these cars is because this is a racing car, they provided these little flaps right here. There's one here and one here on the back of the car to protect the shocks and the suspension area from debris. The reason that is such a big deal is, one, it tells me that this is a racing car, and two, the manufacturers went through a little extra detail just for customer convenience. This shows me that they paid attention to detail when they were designing this car, because they put something as small as a little flap there to protect all of this from the debris from the front tires. Now, another interesting thing is the shocks on this car. This car has 4 shocks, and it has aluminum shock towers on the front and the rear of the car. And aluminum shock towers are good because when you go over jumps or you hit bumps, these shocks and the shock towers have a lot of force that they are subject to when you hit bumps. And the reason it's important to have aluminum shock towers is it's a lot more durable than plastic. So that is good. For the shocks themselves, they have these twistable adjusters here where you can adjust the ride height. You can move them up and down to give you softer or stiffer suspensions. And another interesting thing is these shocks are filled with oil, just like a real car. So you can put different weights of oil in your shocks for different performances. I just prefer to go with the stock oil because it does just fine. But these shocks are heavy duty shocks. They have a rubber boot on them to protect from dust and dirt, which is just another example of how the manufacturers went just a little bit further just to give you a professional racing car. Now, another interesting thing is you'll notice here we have these little adjusters right here, and a lot of cars don't have these adjusters. These adjusters are for the tire, how the tires will align. So if you want these to turn in or out a little more, you can adjust these linkages here, which gives you adjustability as far as like how your car handles. So just, you can see they have them on all 4. They have them on the rear and the front, and that is great for adjusting just your wheel alignments, because some cars don't have that. So the fact that these ones do is also a big plus. So another interesting thing is the heat management. Now, I mentioned in one of my earlier videos, this has an emergency pull plug where you can pull this plug out if there's a fire, and that will kill power from the battery. Another thing for the cooling of this car is you have your fan here for your ESC, and then you have your motor here. Now, something that a lot of people don't realize about your motor is, yes, a lot of guys will you can install like fans here, like for the motor. I have yet to do so. But another interesting thing that people don't necessarily notice is you can have heat transfer by conduction, which is direct contact. And this motor is sitting on this metal chassis right here. And the reason that is a big deal is because this underside of the car acts as a heat sink for the motor. So when the motor gets hot, the underside of the car itself actually gets warm, which is good because it's taking heat from the motor and dispersing it through the underbody of the car. So that's just a basic overview of just some of the energy management systems in this car, and I find it very interesting. It's a lot of fun to drive and race these RC cars. So thank you guys for watching. Please like and subscribe and be on the lookout for more videos in the future. Thanks guys. Have a good one.